Imagine you're baking cookies. The recipe says 2 cups of flour, 1 cup of sugar, and 1 egg. If you add too much or too little, the result changes completely. Chemistry works the same way. Atoms and molecules react in fixed ratios, and stoichiometry is simply the way we count them. Let's go a little deeper. Atoms are unbelievably small, so small that counting them one by one would be impossible. That's why chemistry uses a special counting unit called the mole. A mole is like a chemist's dozen. Just like a dozen means 12, 1 mole means 6.02 times 10 squared U particles, a number so large it lets us work with atoms in measurable amounts. Here's something even more interesting. Different substances have different masses, even if they contain the same number of particles. That's where molar mass comes in. Molar mass tells you how heavy 1 mole of a substance is. 1 mole of carbon is light. 1 mole of iron is much heavier. Same number of atoms, different total mass. But wait, here's the twist. Chemical reactions don't care about mass directly. They care about number of particles. That's why reactions must be calculated using moles, not grams. Stoichiometry connects what you can measure in the lab, mass, to what actually reacts, atoms and molecules. Let's connect this to real life. Medicine doses, fuel efficiency, making fertilizers, producing materials in factories. All of these depend on using the right proportions, no more, no less. Before we wrap up, remember this simple idea. Stoichiometry is the bridge between the invisible world of atoms and the visible world of measurements. And that leads to the next question. If reactions happen in fixed ratios, what happens when one reactant runs out first? What limits the reaction? That's exactly what we explore next.